Hello everyone, in this video we're going to talk about similar figures. So how do we get a similar figure, or what two shapes would be similar figures? So let's start off with our first bullet point. It says a dilation or a sequence of dilations and rigid motions would take us from one shape to another shape, and those two shapes would be considered similar. Because remember, we've talked about a dilation before. A dilation is when we are changing the size of the shape, right? The shape itself is not changing, right? If we started with a triangle, we're still going to have a triangle, but maybe we enlarged the original shape, or maybe we reduced the size of the original shape. So when we have two figures that are similar, one can be obtained from the other by a similarity transformation. So that means we definitely had a dilation, but then we could have also had one of our rigid motions that we've talked about previously, a translation, a rotation, or a reflection, right? As long as we've had a dilation with those rigid motions, then it would be considered a similarity transformation. So similar figures have the same shape, but not necessarily the same size. So let's talk about how that would come into play in terms of the side lengths and the angles of the shapes. So notice down here to the left, the side lengths, they are proportional, right? Which means if I do side length AB divided by side length DE, because those are corresponding sides, that ratio should be equal to BC over EF, which should also be equal to AC over DF. So all of those ratios should be proportional, right? Which means we could set up a proportion. This ratio equals this one. If we have a problem where we're trying to find a missing side, we can always cross multiply to solve for that missing side. So that's the side lengths. Now over here to the bottom right, we see angles. The angles, though, are not going to change degree, right? They're not going to change the size. The measure is going to be the same. And that's what this symbol here means, right? Angle A is congruent to angle D. We see those with our arcs here, 1 arc, 2 arcs, and 3 arcs, right? So we would say that A and D are congruent, angle B and E are congruent, and lastly, angles C and F are congruent. Okay, so let's look at 3 examples and see if we can apply what we've talked about so far in the video. So for 1 and 2, it says determine if the shapes would be similar given the coordinates. So what we're looking for here is, do we have a proportional relationship with the coordinates? Or, in other words, does the scale factor, did we multiply by the same value for both x and y for all of our coordinates? So let's look at our first example. We have triangle ABC and triangle JKL. And notice the point here, point A, we have 0, 4, and then we get 0, 8. So it looks like we are multiplying by 2 there. So let's see if that pattern holds. 4, 4 to 8, 8, that would be times 2. And then 4, 0 to 8, 0, also times 2. So we would say yes, for number 1, those two shapes would be similar because we can tell that their side lengths are proportional, right? We multiplied by a scale factor of 2, okay? All right, for number 2, we have triangle XYZ and triangle MNP. So we're going from 1, 0 to 3, 0, so it looks like we're multiplying by 3. 0, 3 to 0, 9, good, times 3. And then we go 2, 3 to 6, 8. Well, 2 times 3 is 6, but is 3 times 3 8? No, it's not, right? So we would say no for this one because that proportionality amongst all the sides or amongst all the coordinates does not hold all the way through. So we would say no, those two triangles are not similar. All right, last example here for this video, we have trapezoid A and trapezoid B. They are similar. We want to find the missing side length, which is represented here by our variable x. So the key here is that they told us they're similar, right? Which means any corresponding side lengths should be proportional. So let's do this. Let's say we have 5.5 from this side here. That should be the corresponding side to 22. And then we're going to say x over 14 because these two sides would be corresponding as well. So now we can just cross multiply. So 22x. And then we can do 5.5 times 14. So we do 14 times 5.5, and that gives me 77. And then let's divide that by 22. So we see that x should be 3.5. So we could write that right there, 3.5 inches for that missing side length. Okay, and that's what similar figures are all about.